Welcome everybody to our aluminum sorting webinar. My name is Michelle Wiemer. I'm in charge of communications at TOMRA Recycling and your host for the next 45 minutes. We are broadcasting from Germany, the UK, the Netherlands, and Sweden. In order to warm up a bit and decrease the distance between us as much as we possibly can, we'd like to start with a quick poll and learn where you come from. So let's give it a try. Okay, I'm curious to see where you come from and who of you started early in the day and who of you already finished. So some more seconds left. Okay, so the majority seems to come from Europe, so this is great, but we also have some early birds from the Americas, so good morning over there, and also from the eastern part of the world. Thanks a lot. So you're among about 400 registrations, so thank you very much for joining. Now that we got to know each other a bit better, I'd like to take you through a couple of announcements for this session. First of all, you're all muted. We neither hear or see you. Moreover, the webinar is recorded. So in case you can't join until the end, don't worry. The recordings will find their way into your inbox in the next days. You can look forward to 4 presentations done by 2 speakers from TOMRA and 2 experts from the industry. They're going to share valuable insights from their field of expertise. As this might trigger some questions on your end, you have the chance to use the chat box on the right-hand side of your desktop to pose any questions you might have. We are going to pick them up in our closing Q&A session and clarify as much as we can. Last but not least, we'd highly appreciate if you could take like 1 minute more at the end of the session to submit a survey and answer some questions that would help us improve our future webinar experiences. With that out of the way, I think we can start with our first guest speaker, who is Patrick Ragnarsson, Senior Manager, Automotive and Transportation at European Aluminium. Only recently, we interviewed Patrick on the general trends in the automotive sector, and here especially with regards to the electronic vehicle production and the role aluminum plays within the sector. I don't want to reveal too much and would suggest to now start the video and listen to Patrick. Enjoy.
My name is Patrick Ragnarsson, and I'm managing the Automotive and Transport Market Group in European Aluminium. And European Aluminium is the association for aluminium producers in Europe, ranging all the way from primary producers through extrusion and flat roll product producers to the producer of recycled aluminium. And currently we have more than 80 direct members in the association. This is a very interesting time indeed. We can see now that the switch to electric vehicles is going faster than ever. And many car manufacturers are now coming up with the first fully dedicated electric vehicle platforms. This means that the production is going faster and the cars are becoming gradually more affordable to the normal person. And this development is of course driven a lot by the strict CO2 regulations the car manufacturers have to live up to. What we've seen so far is that in terms of total aluminium content per vehicle, electric vehicles use much more aluminium than conventional cars. Most battery boxes that are on the market today are very aluminium intensive. And we also see that lightweighting seems to play a very important role also for electric vehicles. These vehicles often weigh in at more than 2,000 kilos. So keeping the weight down as much as you can is important for the drivability, for the energy efficiency, but also for making them fun to drive. few years ago, we published the latest market forecast. And in that forecast, we estimated that the aluminium demand per vehicle would grow from about 180 kilos in 2019 to a bit over 200 kilos in 2025. And this forecast was, of course, based on the best knowledge we had at that time. What we have seen after that is that the increase of the sales of electric vehicles have gone much faster than we thought. So if I would make an estimate today, I would say that the demand for 2025 might be even higher than that. Well, first of all, the CO2 targets for 2025 and 2030 is set as a percentage reduction compared to 2021 level. And for 2025, the reduction should be 15%, and for 2030, the reduction should be 37.5%. And in addition to this, the car manufacturers can get a somewhat easier target if they live up to a certain level of sales of zero and low emission vehicles, where zero and low emission vehicles are basically defined as electric vehicles and plug-in hybrid electric vehicles. The sales target for 2025 is 15%, and the target for 2030 is set to 35%. This is the current status. So what complicates it even more is that we are expecting the Commission to come forward with a revision of this regulation this summer to align with the basic overall climate targets that were recently agreed on. So we can expect that these targets will be even tougher, but how tough they will be, that is something we will have to wait and see. But the targets are, of course, affecting the OEMs a lot. If they don't meet the targets, there is heavy fines to pay for them, first of all. And also, as there are incentives to sell zero and low emission vehicles, it will affect them into investing more into the development of electric vehicles and plug-in hybrids. But also, as many of the cars are still conventional and the targets are very tough, the manufacturers need to use every tool in their toolbox to try to reduce the CO2 emissions from the cars. And here we see that lightweighting is something that is growing of importance. I think the most obvious challenge is something we mentioned earlier as well, is that we need to be prepared for a future where the casting of engine blocks cannot absorb all the mixed scrap that comes from end-of-life vehicles. And this is something we need to address together and from many different angles. And first of all, I think we need to find new products where we can use these secondary foundry alloys and use the mixed scrap in new products, not only the casting of engine blocks. We also need to work on improving the sorting of end-of-life scrap into more fractions and cleaner fractions, so it can be used for other products as well. And thirdly, I think we need to find ways to include more end-of-life scrap into not only casting alloys, but also into the wrought alloys, like extrusions and flat roll products. First of all, we know that aluminium is a perfect material for future cars, and that the demand for aluminium is expected to grow very, very fast and continuously. And if we can only address the challenges we talked about earlier, I think the future, both for the recycling industry, but also for the aluminium industry as a whole, is very bright.
Thank you very much, Patrick. I already have some questions for you, so I hope you're prepared for later. For what we've seen and listened to now is that there is an increase in demand for lightweight cars, and as a consequence, also for aluminum. If you now wonder how we can build the bridge between an increasing demand in aluminum and a sustainable production, I can reassure you that our experts, Tom Janssen and Terry Keyworth, both segment manager for the metals recycling business at TOMRA, can clarify. Tom and Terry, the stage is yours.
Thank you, Michelle. Good afternoon. It's a pleasure to be here today with you all. My name is Terry Keyworth. I am Segment Manager Metal Recycling, responsible for Northeast Europe and I'm based in the UK. So today, Tom Janssen and I will speak about the upgrading of various types of aluminium scrap using the latest sensor technologies. First, I would like to give a short introduction about TOMRA. Then we can look at the market drivers and trends expected in the aluminium industry. After a short explanation about X-ray transmission technology, Tom will give some examples on how this technology can be used for sorting various types of scrap. Tom will then close highlighting some new developments that provide additional opportunities for recyclers and processors of aluminium scrap. So first, a little bit about TOMRA, which is a Norwegian company listed on the Oslo Stock Exchange. So one part of our business is TOMRA Collection Solutions, which focuses on the reverse vending machines for collection of plastic and aluminium packaging, for example. So the second part of our business is TOMRA Recycling and Mining, which consists of two business streams, mining and recycling. Then the third part of our business, TOMRA Food, which specializes in sorting solutions for the processed and fresh food sectors. So TOMRA is a pioneer in developing sensor technologies, which is being used for many different markets and applications, whether it is for collection or sorting of food, minerals, or recycled material. So within TOMRA Sorting, we have more than 19,000 sorting units installed worldwide, of which more than 7,000 units are being specifically used in the recycling sector. So we can now explore in a little more detail the trends and market drivers expected in the aluminium industry. So demand for aluminium in Europe is expected to grow to around 18 million tons by 2050, which will be an increase of around 40% from 2018. So the key drivers will be automotive, construction, and packaging sectors. And as was already explained very well by Patrick, the automotive sector will have a demand for further lightweighting of vehicles as global legislation becomes even more stringent. It's important to note that the lightweighting is a key element that will enable automotive OEMs to continue to meet this next generation of emissions targets. So the construction sector, complying with the EU Green Deal to become climate neutral by 2050, will really have to focus on more energy efficient buildings and systems. And then the packaging industry, with increasing collections and recycling rates for beverage containers. So we can see all these factors will require really huge growth in recycled aluminium, which is driven by limited primary production in the EU and the circular economy pushing legislation for CO2 reduction and in turn incentivizing recycled content for new products. So with the aluminium demand continuing to grow in the next decades, there is actually a huge contribution that the aluminium industry can make on decarbonising the economy. For a large part, this contribution centres around the use of renewable energies for primary production and the need to use increasing amounts of recycled aluminium for secondary production. As is clearly stated in the European Aluminium Vision 2050 report, the goal for Europe must be to increase the aluminium recycling rates wherever it can, which requires innovation in collection and sorting of aluminium. So let's take a look at the sorting technologies for aluminium scrap that are crucial to reach this goal. So the technology that is being used by many aluminium scrap processors is X-ray transmission, which I'm sure most of you are very familiar with. So X-ray transmission technology sorts based on the difference in atomic density. TOMRA actually launched way back in 2004 the first extract sorting machine. And meanwhile, we have more than 150 units in operation worldwide for metal and aluminium scrap sorting. So these machines are predominantly used for sorting of heavy metals out of a Zorba fraction, for example, and sorting mixed aluminium into really premium aluminium qualities. Historically, the sorting applications were limited to heavy metal and aluminium. However, the technology of TOMRA has now been really further developed and optimized to get higher product purities, to sort magnesium, and to sort even smaller grain sizes, for example. The introduction of the magnesium and superlight sorting task and the fine sorting task will be explained in a little more detail by Tom later. So right now, I would like to hand over to Tom, who will explain how the TOMRA extract technology can be used to upgrade various types of aluminium scrap. So Tom, the stage is yours.
Thank you, Terry. Welcome, everybody. My name is Tom Janssen. I'm a segment manager for metal recycling Southwest Europe. I've been with TOMRA for 10 years, and I'm based in the Netherlands. So we speak about XRT technology, which is the proven and most widely used sensor-based sorting technology when it comes to the sorting of various types of aluminum scrap. So I'm going to show you some examples of what is possible with XRT technology, what are the typical qualities of these sorted aluminum scrap products can be for different input materials, such as Zorba, twitch, and shredded aluminum profiles and sheets. So Zorba, I'm sure everybody is familiar with this. It's a very standard fraction of mixed non-ferrous metals generated basically at any metal scrap recycling operation. In a dry sorting process, the Zorba is typically sorted by X-ray transmission to remove first the heavy metals out of the mixed aluminum. Of course, this step can also be done using dense media separation or flotation. So these mixed heavy metals can be further sorted into their monofraction of copper, brass, or zinc, for example, by color sorting. Then on the other side, the twitch quality is a mix of all the aluminum alloys. Now, in recent years, more and more recyclers have implemented a second step with X-ray transmission to further upgrade this twitch fraction. So by using X-ray transmission, it is possible to sort out the low alloyed aluminum alloys from the higher alloyed aluminum alloys in terms of their heavy metal content. So the goal here is to really concentrate the wrought alloys and produce a premium quality aluminum, where after melting, levels of copper and zinc of around 0.1% can be reached. So there is a significant added value for this fraction, and it allows recyclers to have additional channels to sell directly to the smelters, also the ones that require higher qualities compared to the twitch material. And depending on the grain size and the input of the shredder, there can be about 40 to 60% of this wrought aluminum in a mix of typical Zorba. So this slide shows the process from one of our customers who are processing aluminum profiles and mixed aluminum sheet. This customer is operating a typical shredder process using a hammer mill, magnet, and eddy current separator. The product from the eddy current is still contaminated with heavy metals and aluminum alloys containing higher amounts of heavy metals. And therefore, they screen the material into 3 different size fractions, and they remove the contaminations using 3 XRT units in parallel. The ejected fraction is about 4 to 5% of the input and can be further sorted, again, to recover the copper and brass. The aluminum product of the 3 sizes is then mixed together and sold to the remelter, They remelt the scrap into billets of 60/60 alloys in this case, which are then used in their extrusion plant to make new profiles. The melt analysis of this final product, which consists of around 85% of this post-consumer aluminium scrap, shows that the content of zinc and copper is around 0.02 to 0.04%, with the iron content being around 0.2%. If they would use an input of mixed aluminum sheet instead of profiles only, the content of zinc and copper is typically a little bit higher due to the presence of different alloys, but still it is in the range of 0.07%. So these contents can be achieved thanks to the TOMRA extract technology. And there are many other customers worldwide who run a similar operation. So we clearly see that the market trends towards greener aluminum, towards increased recycled content, as was also explained by Patrick and Terry, really create opportunities for both the recyclers and the processors of aluminum. So from the perspective of a remelter who uses the sorted post-consumer scrap in their furnace, there are several benefits. First of all, the amount of secondary or post-consumer scrap used in the melt can be increased, or at the very least optimized, when the content of zinc, copper and iron is low and consistently low. I think consistency is the key word here, as it is very important for the remelters to know and to rely on the quality. Of course, when using more scrap, the energy consumption will be reduced. And in addition, when using cleaner scrap, the amount of dross is reduced, which leads to less cleaning of the furnace and increased production capacity or tap-to-tap time. The information in the bottom is data we received from one of our existing customers. So these numbers reflect their financial benefits for them as a remelter from the moment they started using scrap sorted by X-ray transmission compared to the situation before when they were using unsorted scrap. So they were able to double the amount of post-consumer scrap instead of using primary, which based on the price difference alone gave them approximately €1.5 million benefit per year. Then they were able to reduce the gas consumption by 6%. And finally, the production capacity was increased by 2%, which led to roughly €1 million benefit annually. So for them, in addition to supplying greener aluminum with higher recycled content, it's also clear that there are commercial and operational benefits as well. So to close, I would like to share some recent developments that TOMRA has made in our XRT sorting technology. The first one is the XRT Fine Sorting. This unit features a high-resolution sensor, which provides sharper X-ray images compared to the standard XRT version. And therefore, it has a higher precision specifically on the small and thin objects, such as copper wires. So on the right side, you can see an X-ray image, which shows that with this new high-resolution sensor, the difference between even small, thin objects of heavy metals and aluminum is quite clear. So especially for sorting Zorba fines down to 5 millimeter, for example, the higher recovery of heavy metals with this XRT Fines technology can have really a significant benefit, and it allows the production of an aluminum fraction ready for melting. Another development is the removal of magnesium and superlights. So depending on their exact process, aluminum smelters can face many potential problems with scrap that contains high magnesium content. For example, there can be an increased pot time leading to higher energy consumption. Extra additives are needed for chlorination to remove the magnesium. the addition of primary aluminum to dilute, or an increase in magnesium waste products as dross. And then there are other superlight materials, as we call them, which can cause similar problems. So these superlight materials can be aluminum compounded with plastics, such as aluminum sheets with a layer of rubber in between, heating tubes, or condensators. So with the latest XRT sensor technology, it is now possible to sort out magnesium and superlight material from the aluminum, which provides new opportunities for recyclers and processors to create even cleaner aluminum fractions. So with that, I would like to thank you for your attention and hand the stage back to Terry to summarize. Terry, the stage is yours.
Thanks, Tom, for your very interesting insights. I would now like to summarize what we have presented today. We have seen that there is a clear goal for all sectors in the aluminium industry to increase the amount of recycled aluminium being used in new products. The utilization of current available sensor-based technologies, as well as future developments, are providing opportunities to aluminium recyclers and processors to produce high qualities of scrap, thereby helping the industry increase the aluminium recycling rates to achieve the low carbon roadmap set out in the European Aluminium Vision 2050 report. With this, I would like to thank you for your attention, and I can now hand the stage back to Michelle. Thank you.
Thank you very much, Tom and Terry. Now that we've learned how sensor-based sorting can be beneficial for both recyclers, for the industry, as well as for the environment, we'd like to know whether you are already using sensor-based sorting technologies and reaping the benefits from it. So let's do another quick poll in the next 10 seconds. You're curious to see who's already benefiting from it. Okay, let's give us another 5 seconds before we resolve the poll. Okay, so there are more people that don't use it yet, but good to see that we also have a lot of you that already use this technology. So, and for all those who do not use it yet, but might consider applying it in the future, we advise you to closely listen to our next guest speaker, who is Edward George, Commercial Manager at Aluminium Trade, a huge scrap recycler in the UK and one of our customers. Edward is now going to share first-hand experiences and explains how sensor-based sorting technologies enables him to offer a full closed-loop recycling solution. Edward, the turn is yours.
My name is Edward George, and I am the Commercial Manager for Aluminium Trade. We are a specialist aluminium recycler in the UK. I would say that there's a split. 70% of the business is aluminium extrusion, sheet, plate, and swarf recycling. The remaining 30% would be aluminium cans. That's can-to-can recycling. So we purchase waste aluminium cans in, we sort them, we clean them, and they are supplied to remelts around the world to be melted back into aluminium cans. We see an increase in consumption as new buildings for both residential and commercial use take advantage of the thermal, UV and aesthetic benefits that aluminium gives to windows, doors, and curtain walling as well. Sensor-based sorting has changed the way that we are able to process material. Historically, we've processed pre-consumer fenestration window scrap extrusions. So we've been able to separate the polyamide strip away from the aluminium, which has been hugely advantageous to our business. So much so we're probably processing around about 10,000 tons a year of this material to the fenestration sector. The challenges we found were with regards to post-consumer material. So the post-consumer material is the material that's coming out of either demolished buildings or replacement windows and doors for houses. And the issue is that the aluminium windows and doors contain other metals, so coppers, brasses and zincs. The issue there, separating that material by hand as it used to be, was extremely time consuming. So the sensor-based X-ray technology that we've incorporated over the last 3 to 4 years here at Aluminium Trade has enabled us now to process, I would say, upwards of 100 tons per month of this material. So it's been a really good addition to our business and enables us to support the fenestration sector with both the pre-consumer and the post-consumer scrap, so we can offer a full closed loop recycling solution. I think there's more and more demand for the recycling of all materials. Not all materials can be recycled, so it's down to the manufacturers to liaise with recyclers to see the best processes that could be put into place. We also see a high demand for recycled content. So this means separating materials fully to demonstrate credentials, to commit to reducing CO2 levels. I think with aluminium being infinitely recyclable and a strong recycling infrastructure in place, aluminium is a critical component within the circular economies. Recycling aluminium, it only uses 5% of the original energy taken to mine it in the first place to produce a primary material. So it is an extremely green material to work with. We look at the automotive industry and the advancement of aluminium within that area. With aluminium being such a young metal as well, I think there's other sectors out there that maybe don't know how good a material it is to work with. So the sky's the limit with regard to various industries in the future, looking at aluminium in all its forms as an advancement to produce new components, new parts. Who knows? I think the opportunities are endless for the material.
So thank you very much, Ed, for your insights. We now reach the last point on the agenda, and I would now like to call all the panelists on stage for the Q&A session. I hope you're prepared because we have quite a lot from our still more than 200 participants in our session here. Okay, here we have Patrick. Welcome. Tom is also here. Jerry and Ed. So, welcome everybody. So, I hope you're ready to start with the first question that I can dedicate to Terry. So the trends you described in your presentation mainly related to Europe, but how do you see the trends in the rest of the world?
Thanks, Michelle. We actually see similar trends in US and Asia. We have customers with sorting plants in Asia, Middle East, and the US for many years, sorting Zorba as well as profiles and sheets. So this type of plant is also driven by commercial benefits, not only legislation. However, the trend of greener aluminium, I think, increasing recycling content and decarbonisation are global topics. So I think the trend will continue to grow.
Thank you. Just speaking of the growing trend, I have one for Patrick. So how many people do you think will drive electric cars in, let's say, 10 years?
Well, that's a good question. Very difficult to answer. I think if you asked me a few years ago, I would be much more pessimistic than I am today. I think we've seen basically during the last year a huge increase of the uptake of electric vehicles in Europe. And also seen a lot of studies pointing out that rather soon there will be more or less an equal cost level driving electric and driving a combustion vehicle. I think if you look at the European regulations, so they stipulate in 2030 that around 30%, 35% should be zero or low emission vehicles. And I think that's low. I think it could be even higher than that.
Thank you. Now that we're still with the topic of vehicles, how do you think the recycling of end-of-life vehicles can be improved? Maybe also for you, Patrick. Shall
I start? Yep.
Yeah.
I think within European Aluminium and with our members, we had a look at this actually last year. And as I said in my interview as well, we need to look at the future where there will be less casting of engine blocks. We need to find a new way to use the aluminium that comes from end-of-life vehicles. And what we looked at was if it would be possible to dismantle some key parts of the cars before you shred it. So let's say take out the doors, take out the hoods, shred them separately, and then sort this material, because then you would have less alloys that will be mixed. It will also be an easier target for the sorting companies to sort it into more interesting fractions that can be used for sheets or extrusions in the future. So I think that's one way. I think the project looked at this and said that it's technologically feasible. It's just about finding the right volumes in the market.
Thank you, Patrick. Does maybe Tom have something to add from the technology side?
I think Patrick is right. I think if you look at also the development of the technologies, how they have developed in the last years. So we have more and more capabilities. So as I explained, we are with the XRT technology, we are capable of reducing the heavy metals, so the main alloying elements already down to very low levels. But there is a limitation, especially like silicon, which is also an important alloying element. And the silicon typically comes from the engine blocks, from the casting scrap. So yeah, it makes sense to do some sorting before mixing everything in the shredder. That will help definitely the recyclers and our sorting technology to make better qualities. Yes.
Thank you, Tom. Now that you mentioned improving the steps before sorting, I have another question, or the first question for Edward. What is the best way to process incoming aluminum before sorting?
So the way we find it's easiest is to shred the material down. So we have hammer mills which shred material down to fraction sizes. We find work best between sort of 30 and 50 millimeters. We find that we can achieve a greater separation with the material at that fraction size. And with the advancements that we've invested in the X-ray technology, I think we're running 2 XRT machines here at Aluminium Trade. We've really been able to up the production capacity with regard to post-consumer extrusion scrap from the fenestration sector, which has really been advantageous towards our business.
Thank you. So you seem to be really happy with the way you sort the materials with the solutions available. One participant asked whether you intend to buy even more or integrate even more sensor-based sorting solutions in your plant.
Yeah, I think we do. I mean, we've recently made an investment in a Bonfiglioli Drake 16 hammer mill, which is due to be commissioned in the course of the next couple of weeks. So we've always predominantly focused our X-ray technology toward the fenestration sector. With the addition of this new hammer mill, it will really sort of open up other industries for us to explore, automotive sector, rail sector, aerospace, and obviously if we can get into these industries now and purchase material, yeah, certainly we'll be looking to invest more with TOMRA.
Thank you. So I have a question for you, Terry. Can one or the customer modify XRT sensitivity depending on the scrap input quality?
Yeah, so the sensitivity of the XRTs are related to different application packages. So as Tom talked about in his presentation, we have the fines package, which is obviously specific for fines fractions, and then we have various different other application packages for different grades and granular fraction sizes. So yes, this is possible.
Thank you. One more for Tom. Will the TOMRA XRT sorting equipment remove magnesium from the twitch material?
Yes, this is possible with these latest developments. That's the reason is that the development in software, the development in the sensor material. So historically, this was not possible because of the overlapping of the densities of magnesium and aluminum. But now we can see the difference, and it works quite effectively. So we can definitely remove the magnesium out of the twitch. Yes.
Okay, and how many tons per hour can our XRT run?
Well, that depends, of course, on the size of the material and the type of input. But typically, we can run our X-ray at 10 or even up to 15 tons an hour, depending a bit on the composition. But these type of capacities are possible. What we normally do, what most of our customers do, is we have a test center, fully equipped test center in Germany. So customers typically send material to our test center, and we can simulate and test their material at high capacity and send it back to the customer, who can then do a melt analysis. So that's the best way in the end to assess what is the real capacity for their material.
Okay, thank you. I have one more for, I think it's for Terry. It's a bit longer. So listen carefully. Can the TOMRA systems remove low melting elements and tiny oxides, reducing the effect of minor elements on the performance of recycled alloys?
Can you repeat the question, sorry?
Yeah. Can the TOMRA systems remove low melting elements and tiny oxides, reducing the effect of minor elements on the performance of recycled alloys?
Okay, I think I got the point. Well, the TOMRA extract actually separates based on density, and its density of heavy metals. So the sorting of aluminium is into a low alloy and a high alloy fraction. So the low alloy fraction related to Tom's slides, where he showed very low levels of zinc, for example, and copper are easily achievable. And then this depends on different inputs on different levels. So the different input is related to the different alloying aluminium alloys we can produce with the X-ray machine.
Okay, thank you. One more, it's also rather long, but I think it's one for Patrick. If the demand for high quality end-of-life scrap increases as predicted, is there sufficient supply capacity to meet that demand? What do you think?
Yeah, I mean, I think the cars that are recycled today, they are old. I mean, they're normally 15 years old and maybe older. And we know, if you look back in the history, that the aluminium content has increased a lot by the years. So the cars that will come back in 10 years will have a lot more aluminium in them than the cars that are coming back today. So that is one way of securing that we will have more aluminium coming back as end-of-life scrap. Another thing we are working on in Brussels is to try to have the help of the European Commission and the member states to make sure that we can keep as many of the cars as possible in Europe. We've seen in a study now that about 4 million cars per year are leaving Europe without being recycled as end-of-life. Some are left as second-hand cars to other countries, but there are also illegal exports of end-of-life vehicles. And this is something we're asking the Commission now to investigate, and if there is illegal exports, they need to stop it.
Okay, thank you very much. I have one directly dedicated to Tom. So, hi Tom, could you please let me know the sorting capacity you can achieve now? I think it was related to the previous question we had.
The sorting capacity, I think I answered already. That means the throughput, right? So that's more or less the same question. Or do I misunderstand it?
No, I think it's mainly answered.
Yeah, I think so.
Another one for Terry. How can a startup in Africa get into the business using our products?
Yeah, very good question. I think understanding what material you want to process is critical. I think concentrating on one specific input and maybe have an idea of what output and where you can actually send this output is very important. And then develop and build a process around this. I think one of the benefits of XRT technologies is it's very flexible. So it's flexible in terms of different grain sizes to process, and it's also flexible to process different input materials to give very low alloy aluminium to serve different markets. So I think the equipment is very flexible, but I think you have to have a clear idea of what you want to process in the beginning. Quite critical.
Okay. I hope this clarified the question. I have another one related to this for you, Terry. What about small aluminums, like when they're used in food packaging? How are they processed? Is this a challenge?
Food packaging. No, I mean, again, with the high resolution sensors and different packages, particularly on the fines package, we can really see very small wires and thin materials. So this can be either ejected into the let's say the cast fraction with the magnesium and the superlights, for example, and always diverting this type of material away from your premium products, which would be the wrought aluminium. So the different application packages have got different sensors to allow us to process a wide range of different inputs.
Okay, thank you very much. So we still have quite a lot of questions, but we're quite a bit over time. So I think we're going to work on these questions and share them with you afterwards. And thanks again for all participants, for the panelists here, for taking the time. We're still about 200 participants, which is quite good. So thanks a lot. And we will now close the webinar and would highly appreciate if you could stay 2 minutes more or 1 minute as announced in the beginning to give us feedback in the survey that will appear on your screen in the next seconds. So thank you very much. Ciao.